Welcome to our channel. Today we dive into the intricate world of TCP connection service. TCP connection services are connection establishment, data transfer, and connection termination. First, we are going to see about TCP connection establishment. First, the client sends the first segment, that's the SYN segment, in which only SYN flag is set. This segment is for synchronization of sequence of numbers. Now the server sends the second segment called SYN ACK with 2 flag bits set, that is SYN, and ACK. This statement has a dual purpose. First is a SYN segment for communication. In the other direction, the server uses this segment to initialize a sequence number like 13000 for numbering the bytes sent from the server to the client. At last, the client sends the third segment. This is an ACK segment. It acknowledges the receipt of the second segment with the ACK flag and acknowledgement number 13001 here. Also, the sequence number in this segment is the same in the SYN segment 6000. The ACK segment does not consume any sequence numbers. In general, the third segment usually does not carry data and consumes no sequence numbers. Then we are going to see about data transfer.to make sure that each message reaches its target location intact. The TCP/IP model breaks down the data into small bundles and afterward reassembles the bundles into the original message on the opposite end. Sending the information in little bundles of information makes it simpler to maintain efficiency as opposed to sending everything in one go. After a particular message is broken down into bundles, these bundles may travel along multiple routes if one route is jammed but the destination remains the same. For example, when a user requests a web page on the internet somewhere in the world, the server processes that request and sends back an HTML page to that user. The server makes use of a protocol called the HTTP protocol. The HTTP then requests the TCP layer to set the required connection and send the HTML file. Now, the TCP breaks the data into small packets and forwards it toward the Internet Protocol IP layer. The packets are then sent to the destination through different routes. The TCP layer in the user's system waits for the transmission to get finished and acknowledges once all packets have been received. At last, we will study how TCP close connection between client and server. Here we will also need to send bit segments to a server, which FIN bit is set to 1. TCP supports 2 types of connection releases like most connection-oriented transport protocols. First one is graceful connection release. In the graceful connection release, the connection is open until both parties have closed their sides of the connection. Second one is abrupt connection release. In an abrupt connection release, either one TCP entity is forced to close the connection or one user closes both directions of data transfer. In graceful connection release, the common way of terminating a TCP connection is by using the TCP header's FIN flag. This mechanism allows each host to release its own side of the connection individually. Step 1. FIN from client. Suppose that the client application decides it wants to close the connection. Note that the server could also choose to close the connection. This causes the client to send a TCP segment with the FIN bit set to 1 to the server and to enter the FIN_wait_1 state. While in the FIN_wait_1 state, the client waits for a TCP segment from the server with an acknowledgement ACK. Step 2. ACK from server. When the server received the FIN bit segment from sender client, server immediately sends acknowledgement ACK segment to the sender client. Step 3. Client waiting. While in the FIN_wait_1 state, the client waits for a TCP segment from the server with an acknowledgement. When it receives this segment, the client enters the FIN_wait_2 state. While in the FIN_wait_2 state, the client waits for another segment from the server with the FIN bit set to 1. Step 4. FIN from server. The server sends the FIN bit segment to the sender client after some time when the server sends the ACK segment because of some closing process in the server. Step 5. ACK from client. When the client receives the FIN bit segment from the server, the client acknowledges the server's segment and enters the time_wait state. The time_wait state lets the client resend the final acknowledgement in case the ACK is lost. The time spent by clients in the time_wait state depends on their implementation, but their typical values are 30 seconds, 1 minute, and 2 minutes. After the wait, the connection formally closes and all resources on the client side, including port numbers and buffer data, are released. So TCP Connection Services is a leading provider of networking solutions, specializing in TCP/IP technologies. They offer tailored services to businesses of all sizes, ensuring reliable, secure, and efficient connectivity. From initial setup to ongoing maintenance, TCP Connection Services assists clients in optimizing their network infrastructure to meet their specific needs. With a team of experienced professionals, They strive to deliver top-notch support and innovative solutions to keep clients connected and thriving in today's digital landscape.